6:30 now, so we can get started. Okay, welcome to class 7 of Intro to Python Programming. I'm just going to get my stuff set up here. Yep, we only have 2 more classes. This class and the next class are the only 2 classes left. So yep, this class and the next class. All right, let's get started. So let's see, from last class, we weren't able to finish all of the slides for lecture 6, for slide deck 6. So last class, we focused mainly on lists, tuples, and sets. Well, no, that was from the 2 classes ago. Last class was mainly dictionaries. We talked about dictionaries a lot last class, how to create one, how to add new entries into a dictionary, how to access elements of a dictionary. We also went over some dictionary methods. And we got to the range, how to use the range function with the start stop step thing. And then we talked a little bit about built-in functions, and we used a little bit of the ones here with absolute value and int and float and bytes. These are just some built-in functions. And the last thing that we did from last class was we played around with the max and min built-in functions a little bit. So that's where we left off. So now we will pick up with some more built-in functions in Python. So does anyone have any questions about what we went over from last class? All right. So built-in functions. The map function executes a specified function for each item in an iteratable. The item is sent to the function as a parameter. So the map function takes a function and iterables. Yeah. So let's play around with this code a little bit. So in this code, we're declaring a variable x that is a string that says those good developers practice daily. And then we're setting y to a mapping of len, the function, and x.split, which is something that we can iterate through. So x.split, if you guys remember, will split this string into a list. And then we're applying the length function to that. So if we were to print out the result of this, we'll get 5, 4, 10, 8, and 5. And we get those because those are the lengths of each of the words in this X string. So it might be a little easier to follow if we print out the value of x.split. Okay. So what x.split does is that it splits the string x into a list of words, of each of the words in X. And then when we use the map function, we're finding the length of each of the words in this list, in this list that's separated by empty spaces pretty much in the original X. And then of course we're printing out the result in the last line here. So there's a bit going on here. So let's see. So I'll test you guys out a little bit. What do you think will be printed out if I were to change len to max? in this mapping function?
Is it only left with 10?
Let's see. All right, so it looks like when we change it to max, we get for each of the words in this X string, we get the highest word or the highest letter in each of the words. So in the word those, yeah, maybe I'll print out X dot split again so that it's clearer. So in the word those, S is the largest character. In the word good, O is the largest character. In the word developers, V is the largest character, and so on. So that's kind of how the mapping function works. We apply the function, whatever function that we're putting in as the first argument, to pretty much the second argument, which is going to be an iterable. For example, like split, something that we could like iterate through, like a list. So, yep, that is the mapping functions. Maybe there'll be some more examples. Okay. So the zip function takes iterables, can be 0 or more, aggregates them in a tuple and returns it. The iterable that has least length determines the length of the returned object. So what does this mean? Pretty much, you can think of zip as taking two lists and then combining them together into a tuple. So if we have list 1 and list 2, and then we use the zip function on them, we'll get a tuple where the first element is list 1 and the second element is list 2, something like that. And I'm sure there'll be an example here. Yep. So we have a number list, 1, 2, 3. That is a list of numbers, 1, 2, 3. And we also have a string list, which is in words, 1, 2, 3. And then we're zipping these two lists together with the zip function. And if you were to print out results, which is where we are putting the result of our zip. Oh, interesting. So it's just a zip object. We could probably access it like that. No? Oh, wow. Let me. Okay, I wonder how I can print this nicely. Okay, looks like I have to pull out the interpreter for this one. So we have a number list is equal to 1, 2, 3. And we have string list is equal to 1, 2, 3. And then results is equal to zip number list string list. They're the same thing. Weird. Anyway, the result of using the zip function like this is we're supposed to see a dictionary like this. A dictionary where the first, or a tuple, really, we'll see a dictionary of tuples, it looks like, where the first element of each tuple is the corresponding element in number list. And the second element in each tuple is the corresponding element in string list. So it's supposed to look something like this, but it's not printing out correctly in either the interpreter or the IDE, which is weird. But yep, that's zip. The main use of zip is to combine two lists into one, into something that can be a dictionary. That's at least how I've used it. So maybe what I need to do actually is, yeah, I think this is what I need to do. Yep, there we go. So this is one way of, one useful thing about zip is that you can make a dictionary out of the result of zip. So the keys in this dictionary is the values of number list, and the values of this dictionary is the values of string list. Are there any questions about the zip function? I know it might be kind of confusing. All right. So next we have reserved words. So with reserved words, you cannot use these words to name your variables. You guys might have noticed that as you've been going on with this class. So some examples of reserved words are and, break, class, def, if. You can't use any of these words to name your variables. Pretty straightforward. Right, next we have typecasting. So typecasting is pretty much taking one kind of variable, whether it's an integer or a string or a float, and temporarily pretending like it's actually another kind of variable, like something. And I'll explain. Hopefully this will work as is. And I'll have to do, if not, I'll have to do some editing. Okay, looks like it worked. No? Okay. All right. So in this piece of code here, we have a variable x that we're setting to the integer 234. We have a variable y that we're setting to the string ABC, and we have a variable z that we're setting to the string 123. And then we have a new variable a that we're setting equal to x plus y, which is weird because x is an integer and y is a string. So how can we add an integer to a string? Well, we can do that by temporarily casting x as a string using this syntax, str and then parentheses, and then surrounding x in parentheses. So that's an example of typecasting. And we are also setting variable b to be equal to x plus the integer version of z. So if we were to print out both a and b, we'll get this answer down here. So a is going to be a string because because x is being casted as a string and y is already a string. And b is going to be an integer because x is already an integer, and we're casting z as an integer when it's originally a string. So yeah, this was a typecasting demo. Let's see what else they have. Okay, that was it. Any questions about typecasting? One thing about typecasting, it may not always work. So for example, if we try to cast y as an integer, remember that y is just the string that says ABC, we're going to get an error because you can't really change ABC to a number. So yeah, typecasting may not always work. It depends on the input. All right, now we have a little quiz. In Python, dictionaries are immutable. I remember that immutable means that the contents can't be changed. So are dictionaries immutable? True or false? Right. Good job, everyone. The answer is A, false. Dictionaries are not immutable because we can change the contents of dictionaries. Now, tuples are immutable, but dictionaries are not immutable. Next, please select all correct ways to empty the following dictionary. Student is equal to name, Emma. Yeah, so this is just an example of a dictionary. We have a dictionary called student. So we want to find all the ways of correctly emptying the student dictionary. So it's possible that more than one answer here is correct. So A, B, C, or D. All right, so the correct answers are A, C, and D. If A, C, and D are the correct answers. So the only wrong one is B, because that won't clear the whole diction. Well, actually, maybe, well, let's see. Let's see if D will clear the whole dictionary. Yeah, D won't work. Okay. So yes, the correct answers are A, C, and D. And we could test all of them. So del student is one way to delete the dictionary. Student.clear is another way to clear a dictionary. And also just changing student to an empty dictionary is another way to empty the dictionary. So I have the student dictionary here. So doing del students will delete the variable, so it's cleared. Well, okay. I guess this answer is kind of up to interpretation. So it's possible that A could be correct or could not be correct. So what the del keyword does is that it deletes the variable. So I guess it's technically clearing the dictionary or emptying the dictionary, but it's deleting the whole variable. So if you just said C and D, then that's correct too, I'd say. But I'd be okay if you also said A. So the people that said C and D, you're you're right. If you said A, C, and D, you're also right. But yes, C and D will definitely empty the dictionary though. So if we do student.clear here, we get an empty dictionary. If we do students equal to an empty dictionary, then we will also get an empty dictionary. So yeah, this one was kind of tricky, but there's more than one way to clear a dictionary and make it empty. Right, another quiz. What is the output of the following code? Dict1 is equal to key1, key2. Then we have another dictionary, and then we want to print if the first dictionary is equal to the second, true or false. So yep, I'll give you guys a minute to try this one out. All right, so as it turns out, the answer is actually true. These two, Python will say that these two dictionaries are equal to each other because, well, to be honest, I'm not really sure why. Maybe because they're both dictionaries. So I guess one thing we can test is if Python thinks that every dictionary is equal to each other. Maybe because they have the same number of keys and values. Oh, okay. Okay, I see why. I see why it's true. So it's true because in dictionary order the order of the values in the dictionary does not matter. So these two dictionaries have the same exact elements in it. They're just in different order. So if we were to run this code, we have key one and key two. They have the same elements, but they're just in different order. So if we run this, we'll still get true. But if I were to change the value of key one to 17, then what we're going to get is false now because these two dictionaries have different elements in it. So yeah, but it's actually true because the elements are just in different order. Are there any questions as to why the answer here is true? It is A. All right. Another quiz. What is the output of the following dictionary operation? We have a dictionary, and then we're making a temp variable that we're making equal to dictionary1.pop age, and then we're printing temp. So what is the answer here? Is it A or B? All right, so I'm thinking the answer to this will be A, but I'm going to test it out right now. We'll see if I'm right. Looks like you guys think it's A as well. So let's give this a try. Okay, it is A. Yeah, we get a key error. Yeah, we're getting a key error because there is no key named age in this dictionary. So when we try to pop and it looks for a key named age, you can't find any. That's why we're getting a key error here. I am curious about your issue, Ivy, with getting false for the previous quiz question. I would probably check if if you copied the if you copied the two dictionaries correctly, because they both have the same exact values in it. They're just in different order, so they should be equal to each other.
I can
And
check again.
yep, you can what?
I'm gonna recheck or just rewrite it all.
Okay. All right, let's move on to the next quiz. Select the correct way to print Emma's age. We have a dictionary called student that has a key 1 and then a dictionary as a value. Interesting. And then another one too. Okay, so this is a dictionary in the dictionary. So we want the correct way to print Emma's age. Oh, all right, so the correct answer for this quiz is B. And I could explain why. So we know that Emma is in this dictionary right here. It's the value of the first key in the student dictionary. So we want to access this dictionary right here, this value. So we need to input 1 as the first thing that we want to access. So once we put 1 in brackets like this, student brackets 1, then now we are in the correct dictionary. But now that we're in the correct dictionary, we also want to access Emma's age. And Emma's age is the age key in this. So we have to put age as the second thing that we want to access in brackets. So if we were to try this out, one age. We'll get 27, which is Emma's age. So this quiz was a lesson in how to access dictionaries that are nested in each other. Any questions about that before I get to the homework for for lecture 6. All right. So actually, the homework for this, the homework for this, for these slides are optional. So you guys can do it if you want to. If not, that's okay. It's just optional. So for this homework, for this optional homework, you have a list of cars with different. So we have a list of dictionaries actually, because we have these square brackets here. And then each element of this dictionary is each element of this list is a dictionary. And the goal is to sort the list according to the brand's name, to the brand name's length in descending order, longest to shortest, and then print the list out, and then sort the list by year, ascending, and print it out. So this will involve, I think, the key built-in function, the map built-in function, pretty much the things that we went over in these slides today and also from last class. So yeah, you guys can do this homework if you want to. And with that, I suppose we can move on to the slides for lecture 7. So I will take some time to post this code on the Google Classroom so that you guys have this as a reference. All right, the code has been posted. Now I'm going to post the optional homework. Oh, I'm glitchy. Sorry about that. Yeah, just let me know if it continues to be glitchy. Oh, okay, not anymore. Good. Ah, dang it. Oh, actually, there. Whoops. Okay. All right. There's actually more than one homework. So we have one optional homework and then one homework that you guys need to do. So I will go over the one that you guys need to do as well. Okay. So for the homework that is not optional, I mean, of course, you don't really have to do it, but it's part of the class, so you guys should do it to get more practice with the material. But for this homework assignment, we have this string of numbers, the string of comma separated numbers. So the instructions are to convert the list into a list of strings that have numerical characters only.
What does it mean by numerical characters? Does it just mean like the number 1 and the number 2, or like ONENTWO?
The number 1 and the number 2, that kind of thing.
Basically, just convert it into like a list.
Yeah, yep, pretty much. So you would use like nums.split or something, and you have to make sure to split it by comma. So that's how you would do this first part.
Wait, then what's the difference between like the first bullet thing and the second bullet one?
The second bullet, then convert the lists, which should be a list of strings, into a list of numbers using functions we have talked about today. Okay, so I'm thinking that when you're doing x dot split, you have a list of you have a list of numbers, but they're still in string form. So for bullet 2, you have to use typecasting to convert the list of strings into a list of numbers.
So like a string is the one that's like surrounded by like quotations, right?
Yep.
So the first one we convert it into like a list with the quotations around it, and then the second one we remove the quotation things.
Yeah, so like I'll give an example. So let me just delete all this because we don't need it anymore. So you're starting with something that looks like this, like just a string of numbers. So after doing split, or after doing the first bullet where you use split, you're gonna get something that looks like this, where you have a comma separated, like, oh, I'm still paused. Sorry. Okay, I'm so sorry about that. I was still paused. So for this homework, you're starting with just a string of numbers, 1, 2, 3, or something like that. And then after the first bullet, you're going to end up with a list, but they're still strings. So after the second bullet, you're going to have something that looks like this, where they're actually numbers without any quotations. I hope that.
Okay, I got it.
Okay, all right, great. Yeah. So that's what you're working with for this homework assignment. Should be converting the entire list at once. Don't convert them individually. So yeah, you're going to be using typecasting for the second bullet. And then you're going to print out the list of numbers. So yeah, I think there's even more. Oh yeah, there's more. And okay, so then you'll print out the list of numbers. And then you're going to use a function to find the max and min numbers in the list. So you'll use the built-in functions, the built-in Python functions for that. And then you'll sort the list in ascending order. So that's going to be another built-in function. And then finally, you're going to take this second list, this list of numbers, and you're going to use a Boolean expression to compare the length of this list, the length of numbers you currently have. So you're gonna, yeah.
We're doing the first page of that, like slide 28 and this?
Yeah. So you're gonna compare the result of the first few bullets here for the first list. Once you have your list of numbers, you're gonna compare. You can use Boolean expressions to compare the first list with the second list here.
So take the list. So we're comparing the list of numbers to numbers 2,
Yep. So you're comparing nums 1 to nums 2.
or compare the length.
What do you mean, Ivan?
So we basically compare the length of the two lists.
Yep. You can use a Boolean expression to compare the length of the two lists.
Oh, okay.
So you do something like nums 1 greater than or equal nums 2, and then you'll get a true or false after that. Like if you were to print it out. Okay. Any questions about the homework? Any more questions about the homework? Yeah, this one's kind of lengthy. So if you do both the main homework and the optional one, then I'll give you some kudos, some pat in the back, because that's a lot of work. All right, so let me go ahead and post these two. That's been posted. Okay, great. All right. So that was lecture 6. Let's move on to lecture 7. All right. So for lecture 7, it talks a little bit about the Python IDE and how to install it on your system. Well, we already have the Python IDE. I went over how to install it at the beginning of our time together, so we can just skip through the first few slides here. Okay. All right. So I'm sure you guys have been wondering how you can get user input in Python or just in general. So the secret to user input is just this, with the built-in function called input. Whoops. So we are setting the variable x equal to the input function, just input and then parentheses, and then we're going to print s. So if I were to run this code, if I were to type in ABC123 and press enter, then I get my result down here. It just prints out x. So that's how you get user input in Python with the input built-in function. We can do even more stuff with user input. We could also add in a prompt, which will make things even clearer. So the input function also takes in like a string that will appear when Python starts waiting for user input. So I copy, paste the code here. If I were to run this, I get something down here that says enter your college name. So I'm going to enter Virginia Tech because that's where I went to college. And then we get printed out my college is Virginia Tech. And we get that because what I typed in is stored in X. All right. Any questions so far? All right. Okay, think about how we can get a number input from the user. Type in 12 and see what happens. All right, let's try that. Let's type in 12 and see what happens. Right now we've just been working with string inputs, but let's see how we can get a number input. Okay, so enter a number. Let's enter 12 and press enter. And we get an error because we're trying to add a string x into an integer y, which is 10. We get an error. Now, does anyone have any ideas on how we can get around this error based on something that we went over last class?
My Python, I think my Python's not working because instead of like the green arrow next, like the green run arrow, I have like a green like redo button. Kind of.
Green.
I have that too.
Yeah.
Has this been happening the entire time?
No, I think just starting like now.
Okay. Yeah, I think it's doing that because this code gives an error. Okay, so let's see. If we were to change this code to, if we were to put an integer, if we were to typecast x as an integer, That would probably fix the issue. Yeah. So if you were to enclose x, like the value of x inside of an int, like I have here, that might fix the issue. But yeah, what I was trying to get at is we can use typecasting to get around the issue of input only returning strings as output. Let's see what the slides have to say.
Enter a number instead of enter a number equals 12. I'm not sure why.
Oh yeah, okay. So you see enter a number. So go in there and type in any number. Like click on your console at the bottom and type in a number. And then press enter.
Oh, that's cool.
Yeah. All right. So the function gets a string. We need to convert it to a number. This means we need to typecast the string to an int in order to do addition, which is what I just gave an example of. They did it a bit differently though. They said x is equal to int x, and then they printed out both. So that's another way to do it. The slide here. All right. So does everyone understand how we can use typecasting to convert the result of an input to an integer? Great. You can also cast the number to a string, type in 12, and now see what happens. All right, so let's copy this. So here we're doing pretty much the same thing like we did in our code where we changed the input to an int, except we're changing y to a string. So if we were to run this code here, we have our x and our y. Enter a number, I'll enter 117. And then we get 11710 because when you use the plus operator on two strings, it just concatenates them together. So yep, x is a string and y is a string, so we concatenated two strings together. All right, code block. A code block is used to organize a block of code, one line or more, to do a specific process. It is organized by indentation. See a while loop code block below. Well, we haven't gone over while loops yet, so this might be kind of confusing, but the main thing is that a code block is used to kind of structure Python code, and they're organized, and you could like distinguish code blocks in Python. Code blocks are distinguished by indents, by tabs, pretty much, kind of like what you see here. So everything under the while b is less than 10, all that is part of the two lines under that are part of the while code block. And I'll talk more about that too. Try to see what happens if you don't indent the code block. This means those statements belong to the same block. So maybe we should try out this code block. So this is what I was talking about with indentations and everything. So in Python, these two lines down here, the last two lines are part of the while code block. So if you were to run this, it'll run normally and everything. But if I were to remove the two indents here, then we're going to see something different. Yep. It's going to say that Python is expecting an indent after while, because with the while loop, you need things to go in the code block under it. So we need a tab there. So that was an example of a code block. All right. So now we get to conditional statements or if statements. It'd be easier to see in my IDE. All right, so here we have an example of an if statement. We are declaring a variable x that's equal to a user input. The user is inputting a number, and then we're typecasting that input into an integer, and then we're checking if x is. So this is an example of an if statement syntax. So we're checking if x is greater than 0. If it is, then we do one thing. Else if, or ELIF, if x is less than 0, then we're printing another thing. And then we use the else keyword if nothing above the two if statements hold, and then you print 0. So so let's run this a few times so that we can see what's going on here. Can somebody wait, hold on here. Okay. Can somebody give me a number to input? I'll take the first number that somebody says. Six. All right. So let's input 6, and we get positive number. So what happened here is that we take 6 and then we go into the if statement. And then what happens is that we're doing if 6 is greater than 0, and then Python checks if that's true, which it is. And since it's true, then we go into this code block down here. That's why we get positive number. Now, if I were to run this again, and I put in -6, what do you guys think is going to happen if I press enter?
It's gonna print negative.
Yep. Going to print negative. And the reason why it prints negative number is because Python checks if -6 is greater than 0, which it isn't. And then it's going to go to this elif. And then it's going to check, is -6 less than 0? And that's true. So then it's going to go down to print negative number. And then in the case that none of the if statements in here holds, Python's going to go down to the else part. So if I put in 0 and I press enter, Python's going to print out 0 because the first two if statements aren't true. So it's just going to go to the else. All right, does that make sense to everybody? If statements are a very, very important part of Python. And you'll be using it a lot in whatever you do pretty much. All right. I think I'm going to stop the lecture here because it looks like the rest of this slide deck is on if statements. And I think we did and I think it's good that we got an introduction to if statements already. A simple introduction to if statements. So in the next class, in our very last class together, we will continue on with if statements, and we should be able to finish all of them. So, yep, any questions about what we gone over today? All right. Well, thank you guys for attending class today. Our next class will be our last one together, so I hope you guys learned a lot about Python. I hope that I'll help you build better robots that do cool things, and yeah, have a good week, everybody. And if you have any questions about the homework, just let me know.